All right, good. Hey, welcome everyone to this session on ETL 2.0, data engineering for developers. Today we're going to talk to you about some technologies, some concepts, some architectures related to improving your ETL pipelines, making them faster, making them more reliable. Hopefully what we present today will be immediately adoptable into what you're currently doing. Just to maybe get a feel for who's in the room today, how many of us are data engineers by trade? Are we like we're developing like SQL transformations and developing like the actual scripts and the pipelines? Are we like okay, great? Who's doing like the monitoring and auditing of the ETL pipelines? Okay. What about data scientists? Any data scientists? Okay, not as very much. All right. Cool, very cool. All right, so here's our agenda for the day. My name is Mark. My name is Mark. I am a solutions architect for Databricks. Joining me today is Banu Prakash. He works on Azure Data Factory, and Casey Kars, who works with Azure SQL Data Warehouse. So first I'm going to introduce us to Databricks. Admittedly, we'll probably, for everyone in this room, the first few slides will probably feel like level 100 slides. But I promise you, I'm working into level 400 slides, and we're going to do it methodically, so that way when we get there, the concepts and the things we talk about all make sense. So hang with me. I'm going to talk a little bit about Apache Spark and how it helps with developing your ETL and data pipelines. And then I'll be handing it off to the other presenters. We're going to do our best to stop respectfully with enough time to ask questions towards the end. I suppose if you have a huge objection, just raise your hand in the middle. Otherwise, feel free to save your questions to the end. All right, so why is ETL so hard? We could all probably name like 1,000 reasons, but I put together a list of some common issues. We have things like various source formats are different. Maybe sometimes you're building jobs from JSON or some semi-structured data, or you're building it from different types of structured databases. Many times you might have things like schema mismatch. Even the data that you're reading from the same source might have changing schemas. Different types of data can be represented differently. So, I mean, how many times can date time be represented, and all the different types of ways it can be used. You have things like corrupted files and corrupted data. So, how many of us work with like semi-structured data with JSON and things like that? I mean, for Apache Spark and doing like and big data analytics, those types of semi-structured files are an important first part of the ETL pipeline often, and we do have many times corrupt and files and data, and we're going to learn how Apache Spark can help. You'll have scalability issues, right? So maybe sometimes the amount of resources allocated for the pipeline needs to be minimal, and other times it spikes. Do you have the ability to scale out your resources elastically to handle that? What about things like schema evolution? How do you handle things like schema evolution on streaming data? Are you partnered with a technology that can do that? And then those are just really, building the actual pipeline. But then how about putting the pipeline together? Do you have the ability to monitor and audit the pipeline and kick off workflows? What about integrating many different services? I am a solutions architect for Databricks, but I understand my technology works in conjunction with many other technologies. How do we coordinate all of these together? And then the most important one, are you partnered with technologies that allow you to evolve as fast as the business? So here are just some components that help you build a robust ETL system. I put them up here just so you can think about maybe the technologies you are partnering with today. Do you have the ability to do these things? So from a data management perspective, can you work with big data? Can you work with fast data? Do you have reliable, consistent views of the data no matter who is querying it? From a platform management perspective, do you have failover recovery? What happens with do you have automatic upgrade ability? Do you have elasticity in the resources? And then from an infrastructure management point of view, what's the level of complexity that it takes to manage the infrastructure? Are you getting it managed as a service, or are you having to spend a lot of time managing that infrastructure yourself? And could that time maybe be used in other places more wisely to continue building either more robust ETL pipelines or partnering with the data scientists to get the projects they're working with into production instead of just spending time maintaining the infrastructure? So those are just some few concepts I wanted to introduce in the beginning and get our juices flowing about what the important aspects of partnering with technologies for the ETL pipeline. How many of us in here have heard of Azure Databricks? All right. How many of us are familiar with Spark? Yeah, okay, cool. All right, well, okay, very cool. So what is Azure Databricks? It's an optimized Apache Spark platform built on Azure. It's where you can instantly set up workspaces. You can work collaboratively in notebooks. You can do all elements of your data and analytic pipeline, from the transformations, the ETL work, if you wanted to do your data scientist, machine learning, work with streaming data. You get to take advantage of the security and infrastructure of Microsoft, and it natively integrates with all of the services you are already familiar with. It integrates with Azure SQL Data Warehouse, with Azure Data Factory, with Azure Blob Storage, Azure Data Lake Storage, and Cosmos DB. And you could even output results to things like Power BI. So it's powerful and in the application in itself, but it's even made more powerful with the things that it integrates with. You might also hear Azure Databricks called the Unified Analytics Platform. Has anyone heard of Unified Analytics? It's sort of like a new category being created right now. Yeah, this is what I expected. Okay. All right, so when we think of a Unified Analytics Platform, we break it up into 3 pillars. And these pillars are what makes you successful in building your data and analytic capabilities. The first one is a unified experience across all the teams. So for ETL work, do you have the ability to work with the data scientists and their developers who are building up the applications quickly to move them into production? Do you have the ability to quickly integrate and interact with the business's team? Are you removing all of the obstacles to those lines of communication? The other component is unified analytic workflows. Is this a platform where you can perform all elements of your data and analytic pipeline? Can you access all different types of data? Can you do all the different types of transformations? All the advanced analytic techniques that you might want to use? Can you use all languages? With Apache Spark that you're familiar with, you can use R, you can use Python, you can use SQL and Scala to design your data and analytic workflows. And then we have the unified infrastructure. So it's a fully managed, fully automated infrastructure where you get to take advantage of things like fault isolation, resource scaling, and then automatic upgrades. What is Azure Databricks as a platform itself, and why is it more powerful, or what makes it different than just Apache open source Apache Spark? Well, in order to successfully get all of these folks on the left side, who are your data scientists, for those of us in the room today are the data engineers in the line of business, to work collaboratively together to build applications that support all of these use cases that we're working here today to try to advance our businesses, we've developed some specific components in the platform to help make that easier. So the first one is the collaborative workspace. You have a notebook-based environment where you can work together and you can schedule jobs in the Databricks workflows. You can have production jobs and automated workflows. One-click schedulers for your training of your machine learning models. The Databricks runtime takes advantage of years of optimizations and stabilizations that we've learned from in the field. So this means that you don't have to worry about folks submitting commands to the Databricks clusters that on a normal open source Apache cluster it might have crashed it because it asked to, like, maybe return too much data to the driver node, right? We built in lots of stabilizations and optimizations around that. You get to take advantage of things like DBIO, and we're going to learn about that here in a second, but it allows us to compute our jobs faster. So what makes Databricks, our version of Apache Spark, faster than the open source Apache Spark? It's things like the Databricks runtime and what we're going to learn about DBIO. We have our Databricks serverless component, so it's a fully managed, automated infrastructure service where you'll take advantage of things like fault isolation, like I said earlier, and it's an auto-tuning platform. And then, since we're built on Azure, you get to take advantage of the Microsoft security infrastructure. All right, so I want to get into the components of Azure Databricks that allows us to build ETL pipelines faster, and in the end, really it allows us to lower the total cost of ownership of these ETL pipelines, which is not only is it important that we get them done fast and reliable, but in the process, we're lowering the total cost of ownership. So the first one is that you get to take advantage of automatic recovery. So if a cluster node fails, they'll automatically replace with new ones. If the whole cluster becomes unresponsive for some reason, then the cluster will be automatically recovered. And we have automatic upgrades. And this happens at a frequency of about every 2 weeks. We have efficient resource management. So we have auto compute, which is, will guarantee that we are maximizing the utilization of all the nodes in the cluster. So that way, for the nodes that you do want to turn on, you're actually using them, and you don't have to monitor why maybe certain nodes aren't receiving tasks from the head cluster or the head driver. We have auto scaling of local storage, so we automatically scale the local storage based on the disk space requirements in the job. So we've done a lot of work to intelligently look at the jobs that are being submitted to the cluster and to be able to scale up and scale down the compute and storage resources in order to maximize performance, but also to maximize our cost efficiency. So not only is it important that we're utilizing the resources intelligently, but we also want to improve the performance and have faster execution time of the jobs that we are submitting. So here are some items that are specific to Azure Databricks that aren't in open source Spark. The first one is we have the ability to automatically cache remote data. What that means is, let's say you're pulling data from an Azure Blob Storage, and we'll pull it into the local storage. We'll do some computation, and then you get some results. And a normal Spark job, you could cache the results of that job. But in Azure Databricks, we're actually going to cache that first file brought to the local storage, so that way we reduce the amount of times that you have to go back and forth to the storage, speeding up operations like machine learning. We have an enhanced vectorized Parquet reader. So for those of you who are familiar with big data and analytics, if we have our data sitting in CSVs or JSON, we like to move it over into Parquet because it's faster for Spark to read. We have a Spark reader that's specific to Azure Databricks that allows us to pull the data off of the Parquet files faster. We take advantage of things like dynamic query optimizations. So if you wanted to write in PySpark or RSpark or Spark SQL, what happens is the code will get submitted to the driver node, and we take a look at how the code is written, and we have dynamic query optimizations that decides how it's fastest to be computed across the clusters. And so we have our own specific optimizations to speed that up. We can take advantage of things like coarse-grained indexing. What this does is for the data that lives on Parquet files, we index them in such a way that we can actually read them off. We can actually find the data on the files faster by collecting column-level statistics. So for instance, maybe we had a query that asked for give me all folks by the name of Mark in the city of Seattle. Well, we can go and find that column and find M's, and we'll know where to, that we wanted to go and search that column before just scanning all of the files. We have optimized connectors. So for instance, we have an optimized connector for transferring large volumes of data from SQL Data Warehouse. We have optimized connectors for Azure Blob Storage and Azure Data Lake. We even have something cool called file compaction. How many of us in here are working with streaming data right now? And when you're working with the streaming data, you're probably creating thousands of files a day. In order to send a query to thousands of files, that means you're going to have to open up 1,000 files to collect the data on a query. That can be an expensive job. So we put in place things like file compaction that allows us to take the data that we know is represented in the view for that table, compact it into one file or a few files, depending on the size of the cluster that you're using. So that way you minimize the amount of files that you're collecting. So for all of these, for these and there's a lot more capabilities, we speed up the execution of the jobs. More than just making jobs faster, we also try to make developing and maintaining the data pipelines easier. So you get to take advantage of things like ACID transaction. So if you're doing like multi-hop pipelines and you have a raw table, and then maybe off of that table you have a transform table, then you have an aggregated table, and then you have a machine learning table. All of these tables can be updated with ACID compliance. We allow for things like single row updates. And what's important about a single row update is that it's much nicer to update a single row than it is to have to rerun an entire job to fix a field. We have things like data validation. For instance, if you have a pipeline running and a job fails halfway through and maybe half of the data got loaded into the folder and half of the data didn't, we have intelligent log files which tells Spark which data is valid to be read off of. So this way you have consistent reads of the data no matter if there was a failure in the pipeline or not. So that way the analytics that are being generated off of this is always using the most pristine data. We do things like automatic file management. We kind of talked about that's sort of like the file compaction, but we'll also vacuum up the files too. So instead of having thousands of files sitting in a folder that are no longer useful, after maybe a certain amount of like a time window, we'll vacuum up those files so that way we can clean up the resources. We do things like bad data quarantine. So for data that might not fit a schema or data that might fail, instead of failing the pipeline, we'll just quarantine the data so that it can be looked at a later date. And then I think that connector. And then we have optimized connectors. That probably belongs on the other slide. Any questions about these, about any of these like specific optimizations that we've put into Azure Databricks? So hopefully this is giving you some confidence that this product is designed to help make your pipelines more performant and the management of these pipelines easier. That's just the platform that's built around Apache Spark. So I wanted to talk a little bit Apache Spark and why it's called the Unified Analytics Engine. You're able to perform multiple different types of use cases and tasks with Apache Spark. So you get your Spark SQL and Spark data frames for doing things like transformations. You can work with streaming data with Spark Streaming. You have MLlib for doing your machine learning tasks, but you could also use your TensorFlow or your scikit-learn if you wanted to. And then you have graph computing capabilities. But for all of those use cases technical use cases that build to the business level use cases, you also have all these different languages. So for those of us in the room today who might be good at using SQL because we're data engineers or Scala, and then maybe the data scientists use R or Python, right? We can work interchangeably in the same platform without having to port content from one platform to the other just to help them out. So being able to work with multiple languages in the same platform helps to speed up our ability to create our end output. And then, of course, you get to work with multiple data sources. So you can work with data in blob storage. You can work with IoT hubs. You can work with SQL Data Warehouse, semi-structured data, or even things like images. So this is what a ETL query framework, or like a little framework of what an ETL query might look like. So in this case, we would be pointed at a JSON path, and we'd read in the data. We'd perform, filter and aggregation, some transformation, and then you could write it out in Parquet. So this would be a typical query where you're pulling some raw data, you're cleaning it up a little bit, and then you're writing in Parquet. For Spark, and especially Azure Databricks, the Parquet file is kind of the recommended file type to work with. But this one's a little bit more complicated, but still you can do all of this in the same few, in like, what do we have, 10 lines here. In this case, we're connecting to two different tables. We have a CSV table, and we're connecting to a JDBC path. It's like a PostgreSQL table. We are joining the two tables together on, it looks like name, and we're doing an outer join. We can apply a filter to the ID column. And then again, we can write out the table. So this is what you would think, this is what inside of a notebook you might write for a ETL transformation. When we get towards the end of the session, when we have our Azure Databricks demo, we're going to go into a much more detailed or a much more broken out ETL notebook pipeline. For those of us who've used JSON, Apache Spark has a lot of cool elements for handling things like corrupt records. So in this case, if you take a look, we have like this. We have a key value of like ABC. The next line has only AB, and then we have ABC again. So you can put in some different modes in order to handle these data types. So in this case, if we put in the permissive, that AB falls into a now corrupt record column. But if you wanted to, you could do things like drop malformed. And in this case, it would see that this second row didn't match the schema it was looking for, and then it just dropped the second column. That way, if you're picking up things like, again, a CSV or a JSON data, and the example that we have today, we're going to be looking at a dump of web data. This will allow you to continue on with your pipeline and not have it fail. But you could, if you wanted to, put it into a fail fast mode, and that way it can throw an error if you're expecting the data to be pristine underneath it. And then for handling things like schema mismatch. In this case, we're doing something called schema inference. So Apache Spark's going to open up the first 100 columns. It's going to look at what it thinks the schema is supposed to be, and then it's going to find that all of these in this case are longs. But in the event that maybe the C up here was 5.1, then it would see that it was a double, and it could inference that in itself. This is, in order for Spark to do this schema inference, it has to open up the files. So it's a little bit slower than if you were, or it could be potentially a lot a bit slower than if you were to explicitly define the schema as a user itself. So in this case, if we defined a schema where we just had an A and a B, and then it came back with the D and C, it would pass through the data, but it would null those files. All right, Bonnie, you want to come up for Azure Data Factory?
My name is Bhanu Prakash, and I'm a program manager in the Azure Data Group. So in the next 15-20 minutes, I would give a demo of how to use an end-to-end pipeline with Azure Data Factory and what are the capabilities that you can use to create an easy pipeline. So if you look at the big picture, like a general ETL pipeline starts with data ingestion. So you have your data in your custom apps, business apps, IoT sensors, and different places. So you want to ingest that data, and then you want to store it, blob storage, and then do some transformation through Azure Databricks, and then finally put the transformed data to things like SQL Data Warehouse for analytics and visualization. So how many of you have all the data on cloud? OK. Not surprising. So where Azure Data Factory helps is it is a hybrid data ingestion. It helps with hybrid data ingestion at scale, which is one of its key value props. And with Azure Data Factory, it is basically a fully managed service that not just helps with data ingestion, but it helps with orchestration of the whole end-to-end pipeline that we just went through in the last slide. It also helps with monitoring your pipeline, so you don't have to manually trigger all the tasks, but rather give the tasks to Azure Data Factory, which will monitor your pipeline. And you can set alerts and triggers to see if anything goes wrong with your pipeline. It will send you an alert so that the admin of the ETL pipeline can take action if something goes wrong or something is not working. It has more than 60 plus connectors, which means it can connect with different data sources, whether it's in Azure or your on-premises data sources or other cloud. It also helps with the fact that given it is an on-premises, you can have your own integration runtime, which is responsible for the actual data movement. So before going into a lot of details, let's go through a quick demo and then see to end what the experience looks like. So this is my Azure portal. I go ahead and click on the data factory that I created, an instance of it, and go ahead and click on author and monitor. So it will single sign me on using my Azure Active Directory authentication to my ETL pipeline workspace. Now I go ahead to this monitor, to this author page, where I can go ahead and create an end-to-end pipeline. So this is a very basic demo where what I'm doing is I will first go ahead and create a linked service. What this linked service, which I talked about, it has 60 plus connectors, which is growing. You see that there are all the different data sources, whether it's Azure File Storage, Azure SQL Database, or Couchbase, and so on. So in this case, I am doing a basic transformation. So I go ahead and create a linked service. And as part of the linked service, what I have to do is I just give it a name and then select the region where I'm going to connect to the Databricks cluster. And I have to generate an access token. So as part of authentication with the Azure Databricks, it has to authenticate. So here I'll go ahead and select my workspace. So now I'm logged in to my Azure Databricks. And this, again, if you notice, it's a single sign-on experience. So here I go ahead and say generate token, ADF, and I give it a lifetime, and I select the personal access token that is generated, and give it back to my Azure Data Factory pipeline, right? And then here I can come and select the node type, the Databricks runtime. So let's select 4.0. I can enable auto scaling, since Mark talked about the fact that you can auto scale the compute and the storage. So I enable auto scaling with a min of 1 worker node and max of 4 worker node. And I go ahead and click create, right? So what happens is any pipeline that I will create, I can use this linked service, which will connect me to this Databricks instance. And as part of that, it will go ahead and create a cluster. So that your pipeline will look like it goes ahead, creates a cluster, runs a job, and then terminates a cluster. So you are paying literally for what you are using, right? So in this case, I have a pipeline, which is a notebook. And this notebook basically references here, which is doing a basic transformation. Right? Okay. So let's go ahead and just run this notebook and make sure like everything is working, right? So I'll go ahead and run this notebook just to make sure my transformations that I have captured as part of the Databricks job is running fine. So it ran through 16 commands. And now I go back to my workspace, to my Databricks Data Factory workspace, and just do a trigger. So I'll go ahead and do a trigger now. And you can actually go ahead and define parameters. So there could be different ways. Like one, you can specify a fixed parameter that you know that it is going to go and select a particular record or a file. Or you can specify dynamic parameters so that you know your file or the folders that are generated have a timestamp or a date timestamp, and you can basically provide dynamic parameters so it selects folders that are created on a particular date. So let's say I go ahead and provide some input variables and then click on finish. So what it is doing is it is running the pipeline in this case. So I go back to my Databricks workspace. And what you see here is that it has started creating a job-based cluster. So the cluster will be created, and as part of that, it will run the job on this cluster. And once the job is finished, it will terminate the cluster on its own. So you don't have to manually involve in creating the cluster, running the job, and then terminating the cluster. The pipeline takes care of it. Now let's go back and go to a more advanced scenario. In this case, what I'm checking is I have an on-premises data source. So this is my on-premises data source where I have some raw file. And this raw file is basically a CSV file. So let me go ahead and open this. And in this CSV file, there are certain columns. It has price, products, and so on. So what I will do is, as part of my pipeline, before you even start to do the copy activity, you want to make sure all your input files are copied or available for you to start the job. So in this case, I am checking using this lookup flag to make sure I have some success flag or my last file is copied for me to start the data ingestion. And then, as part of that, once that file is available, then I will do copy to a blob storage. So as part of that, if you see here the source that I have is an on-premises data source. And then the sink that I have is my Azure storage, which is the blob storage. So similar to the way we noticed how we created a link service for Databricks, the same way you would go ahead and create an Azure blob storage link service, and you can select a storage account where the data would be ingested. Once the data is ingested, then I call my transformation pipeline activity using Databricks. So here I give an instance of a Databricks cluster on which you can give an existing cluster, or you can give that, hey, create a new cluster, run this job, and then terminate it, as we saw in the previous example. Once the transformation is done, then you basically do the process data and put it in a store so that your data scientists or data analysts are looking only at the process data. And once the pipeline succeeds, then you send a success email to you as an admin that, hey, everything worked fine, and then you can basically schedule it. So let's go ahead and do a trigger, just do a debug of this to make sure my pipeline, before I go ahead and schedule it, my pipeline is running fine. So I go ahead and provide some values here. So as I was talking about the fact that you can give input variables as part of the parameters, so I go ahead and give some date format. So let's say 2022 will be my input folder, and then 2022 will be my output folder, and then I give the product file, which is where the transformation would happen on this input data. And this is the path of the notebook that exists on my Databricks workspace. And the email should go to me as an admin, and this should be the success message. So I go ahead and click on finish. So right now I'm just doing a debugging to make sure it is actually creating the activities and running. And I can track the activity where stage at it is. So it is right now in progress, and right now it is just doing a lookup to see if the source file, if the flag is there on my on-premises network. And once it finishes this, let's say if it fails, it will email me that, hey, the activity was not completed because of this, and it's a failure here. So you see a green box here, and it indicates that it has succeeded this stage. Now it is executing. the copy activity. So let's go back to my storage account. So right now, I am in Storage Explorer, where I'm checking whether the file has been copied or not. So let's go ahead and refresh. And so we see this folder 2022 that we provided as an input, and let's see if the file has been copied or not. And we see that in my storage account, in the container, the file has been copied. So let's go back to my data factory, and I see that in the progress space, this turns to be green, which means now it is actually in progress of the transformation. So right now, it's doing the transformation for the notebook we actually went and saw. So let's go back to our workspace. And see, so it is executing on this. So let's go to the driver logs and check whether it has transformed the data or not. So I just see the logs, and I see that it has completed the transformation. And again, I'm just showing it as to show like how you keep progress. But as an ETL admin, you don't have to go back and forth, because you would just rely on a single source of truth, which is your data factory. And here now you see that it has completed the transformation. It has processed the data, and then it has put it back into the place where you want the processed data to. So here I have provided that the processed data should go back to my on-premises source where I have the processed data. So here is the sink, right? And let's go back to the on-prem source and go to the processed folder. And then I see this path. It comes in output. And then here I have the processed data, right? Now, if I go back to my Storage Explorer again and go to the output folder, it will also have the different, let's say, if you did not do cols, it will have different multiple files based on how you ran your transformation and submitted the output job, right? So in this case, I have just selected the processing to filter only and collect the processed file in my on-premises sources. Now let's go ahead and click on this to see what is my processed data, right? And as part of the transformation, basically what we did was we sorted the price and then added a new column, which is twice the price of the original one. And so this is my raw file. And since it's on-premises network, so it's taking some time. So here you see this is the transform file, and it has this new column, which is double price, and it has done the transformation on the original file. Now let's go back. So first thing we notice, like you are able to debug, you are able to pass the parameters, you are able to connect to different sources. And then once you have created the pipeline, you can come back here and you can track the progress of how many pipelines have been executed. What is the progress of it? Can I go ahead and set an alert, which we did as part of this? Now, if I go and open my email, I would have received an email that your pipeline has been successfully completed. So while it's opening, you can set an alert through the fact that it has integration with Azure monitors, where you can go ahead and visualize the data in terms of how many pipelines ran successfully. And then you can set alerts on top of if X number of pipeline fails or if X number of activities fail, send me an alert. So let's go back to my Outlook. And what you will see here, I should have got an email, and it says, yes, successful pipeline, right, at 10:52 a.m. Now, this is not a manual email, but basically it's an automated email, which the sender was Abhishek, who is the admin of the ETL pipeline, and I got the automated email. Now I go back to my data factory workspace, and basically we talked about the fact that you can set alerts, and you can also check the metrics in terms of the failure ETL pipelines, the failure activities, all within a single pane of glass. You can receive text alerts, calls, and so on. This was just an example of how easy it is to create an end-to-end ETL pipeline using Azure Data Factory. And with that, I will hand it over to Casey to talk about the SQL data warehouse.
That was my bad. It's always a trick, switching and not making a snafu out of it. So does that make sense to everybody so far, what we've covered? So Azure Databricks being used to actually do some custom transformations, clean the data up, in particular into the semi-structured space where it gets a little bit harder to look into. But the end goal of all ETL, right, is to get it into a data warehouse so analysts can go start making decisions. So we keep talking about Azure SQL Data Warehouse, so I want to talk specifically about it and dive a little bit deeper into why SQL Data Warehouse and what is the architecture. So out of the audience, have any of you used Azure SQL Data Warehouse before, or familiar with it? Wow, that's awesome. So for the folks who don't know about SQL Data Warehouse is the first-in-class, best-in-class Azure experience for data warehousing. It is an MPP data warehouse, which is massively parallel processing data warehouse. So if you're familiar with on-prem standard, kind of the SQL Server type of architecture, you have a single box that's running analytics, right? Single box, taking requests, going after all the data, responding and pulling it back to customers. Now there's times when you try to, say you get more requests or you get more data, so you have to start scaling up. Say I need more memory, I need more storage, I need more compute on a single box. There's points in times when you actually max out what a single box can do. So you start to go into what we call MPP. So you scale out the processing. So this is a classic technique to go after the analytics space. And so this is exactly the architecture that SQL Data Warehouse is built on. So we have 2 generations in the market today. I'm actually very excited to announce that we GA'd our Gen 2 last week. And so we're going to talk about Gen 2 architecture because it's where all the cool new stuff is and it's where all the cool stuff for analysts comes into. So we'll dive deeper into the architecture and talk about kind of how it benefits analysts, how it benefits being the landing point for an ETL zone. OK, we'll skip that. That was just a little snafu. So as I mentioned, we have an MPP architecture in SQL Data Warehouse. So you see here on the right, it's a very simplified view of the world. You have a control node, which is where your analyst will make a connection string call to, and it's where you submit your T-SQL queries. Pretty easy to understand. But underneath, you have compute. And this is a scalable property within Azure. So you can scale down compute and you can scale up compute at will, which is amazing if you think about trying to do data warehousing on-prem when you said, OK, we're running out of space. We have to make a call. We have to call the IT manager and say, you need to put in an ask for the next budget of a couple $1 million for more machines. You pray that that's actually going to come through, and then you wait 6 more months to actually get the machines that you need. This is a click of the button now. So you can scale up, scale down, or pause at any point in time. And so the way we made this happen is we keep the data on remote storage. We actually back all the MDF and LDF files and copies to essentially blob storage at the end of the day. Slightly different. So what you can also do is you can pause at any point in time. So you can turn off compute to save yourself money. So this is a great feature. And so this is in Gen 1 and Gen 2. What we've added in Gen 2 as an added benefit is this idea of intelligent caching. Because anytime you make a remote call to remote data, you have latency in the network, right? It causes some slowness that you might not want. So in Gen 2, we've really optimized that performance piece for analysts to say, let's bring your hottest data to the hottest storage within the database. So at a high level, we have an intelligent cache that you can look at and that you can use. So we'll talk more about what is in that intelligent cache. But the overall architecture is really built and designed in order to scale out queries across multiple compute nodes, parallelize a single T-SQL statement. You don't have to think about how to parallelize it. It just happens. So we can get result sets back to you faster. And we can scan more data and do deeper analytics in the SQL system. So here's a bit deeper look, right? So we took the simplified one, and we actually broke it down, and we're going into the nuts and bolts of what's happening. So you see in the control node, which is a compilation of some cores for CPU, some memory, some SSDs for TempDB, which is where we keep temporary data, right? And then each one of the compute nodes is composed of the same. But you'll see that we have NVMe SSDs as well on each of those compute nodes. So we have SSD memory, and we have a cache as well as TempDB storage. So think of that as a control node. So it has cores, memory, SSDs, a cache, and temporary memory. And then you'll see below the dotted line is where we start to break up storage. So this is actually where we are keeping your remote data. So in storage, we keep snapshots. So we take snapshots of your data for backup recovery purposes. And we can also do geo restores of that data if that's what you're looking for. Now, I don't want to go too deep into databases, because we were talking earlier, and most people didn't really raise their hands if we do deep database stuff. But there's two types of real indexes within the database world. You have row stores, which is traditional clustered indexes, which is basically just make a phone book of my data, and then it's a B tree, and we can go hunt down individual rows. And there's column stores. And you kind of heard about it in the Parquet file format, because that's a column store format. It's actually very interesting that open source has the equivalent. But this is really where you get into analytics. And there's some really great papers out there about column store and how it's revolutionized data analytics. So we support both index types within Azure, or within SQL DW. We support row store as well as column store. But we can do two different things with those, right? So think of column store as you're breaking up the table into column segments, and we can store segments separately. And so we can actually store an infinite number, or an infinite amount of column store data in Gen 2. Because we can break up column store segments and store them separately. We can span them across. And then row store, we store with in the row format, so it does actually need to be in a cohesive order, because that's part of the drawbacks of row store. But it allows very quick lookups for very specific point-in-time records. And so what happens when we talked about that cache, is what we're actually doing is we're enabling. When you query a column store segment, we pull that data from remote storage and we keep it in the cache. And we keep it up to date in the cache, so that you never have to go back to remote storage for that data again. So when you submit a query, it goes straight down to the compute nodes, reads the data, knows it's there, and then produces a result set for you. That's the innovation in this next generation, is that ability to cache data locally and actually have faster performance on analytical queries. And then if you're going to go and query row store in this case, you would go out into the remote store, find the individual lookup, pull that data back into the data warehouse, and present that back to the user. So we highly suggest, as you could imagine, column store is your best friend with SQL Data Warehouse, because it offers better compression and it offers the ability to go into a local cache with the data. So we've just talked about the disk cache for right now. But we also have in-memory caches. So we actually have tiered storage that happens automatically for you within SQL Data Warehouse. And this is per node numbers, right? So we were talking about it's an MPP system, so as you scale up, you get additional nodes and additional capacity for your memory. So we have super hot data, which is about 400 plus gigs per node with 70 nanosecond response times, or NS. So that is the hottest of hot data, right? And that's anything that you're really querying pretty actively. So you can imagine your BI dashboards or dashboards are hitting that data per node. We start at 2 nodes. You have 800 gigs of data ready to go for that query layer. Underneath that, we have 1.5 terabytes of cache per node. And then we can hold infinite remote storage data. And this is CCI segments. So you don't have to worry with Gen 2 SQL DW what's going to happen tomorrow, what's going to happen next year. I'm worried about the future. We've handled that for you, and we've built in caching so that your analysts don't have to feel the complexity that's happening behind the scenes. So data warehousing as an MPP concept, so this is just the same thing turned sideways. But we need to talk about how to get data into the data warehouse, because we're in an ETL talk at the end of the day, right? Like, that's what we're here to talk about. So we have a parallel load mechanism to get into SQL Data Warehouse. And this is where it's slightly different than SMP systems like SQL Server or SQL DB. Because we have MPP architecture, we can take advantage of different routes of getting data in. Smarter routes, faster routes. So we have a feature called Polybase. I'm not sure if you guys are familiar with it, but it lives within a component on the compute node. So there's a DMS, it's called the Data Movement Service. It moves data back and forth. And within that, we have another component called the HDFS bridge. Within that, so it's like a nested dolls here, within that there's Polybase. As from you guys' point of view, it's just a T-SQL interface. I just wanted to give you a little bit of inside scoop on what's happening architecturally. So Polybase lives on each of the compute nodes. And you can say within T-SQL, go fetch or go read this set of files on Blob Storage or Azure Data Lake Store and read them into SQL Data Warehouse. And so what happens when you make that statement is each one of the bridges spins up multiple threads and reads the data in parallel. So there's 8 threads per node. Each of those threads goes out and reads files independently. And again, that scales as you scale out. So you need faster load speeds. You scale out SQL DW. Need slower load speeds. If you want that, you scale down. What this allows us to do is load data so much faster than anything like BCP or a single-threaded process, or if you try to do SSIS or something like that from SSIS to SQL Server, it's a single thread across unless you parallelize that flow. This is parallel by default. When Mark was talking earlier about scalability of the process, this is exactly how it's achieved. And we can, throughout the talk, we've parallelized every piece that we can to make ETL faster and more performant for you as a customer. So providing a technology and no way to use it makes it kind of hard. And so we've done quite a bit of work with Databricks as part of the Azure Databricks launch to implement best practices and make it super easy for you as users to do best practices without having to worry about the complexities. So within Databricks, there is a special connector to connect to SQL Data Warehouse. So spark.read.format and then spark.sqldw. This leverages Polybase under the covers. So it does the parallel data movement for you, and all you have to do is write standard Spark code. So in this case, what we're actually doing is we're saying, I've compiled down a connection string into a single variable just to make it a little easier, but we connect over JDBC to orchestrate, but not to move data. So you'll see a JDBC connection string on the data warehouse side. But what I'm doing is I'm reading data from my SQL Data Warehouse, this dim aircraft table. So I have an aircraft data set. It's one of my favorites. We're reading that from SQL Data Warehouse into Databricks. And this would be if you need to do some referencing during your ETL job, you can read data from SQL DW into Databricks, do the referencing, do the additional munging of data within Databricks, and then you can potentially write it back out. So we'll talk about what the blob storage directory is in a moment, because once we get into it. So the nice part about the connector is it does data type conversions for you. So I don't know how many of you have tried to convert from one data source to another data source, and you start fighting how they're interpreting what a string is and what an int is and what a numeric is. The connector does that for you. So it actually takes the SQL table definition on the right, converts it into Spark data types, into a data frame, and you can immediately use that capability. So it kind of up-levels what you have to worry about on a day-to-day basis for you. But that's the read case, which is kind of strange for ETL, but it does come up where people want to read in dimensional data or reference data from SQL DW where your golden data set is. But the right gets, we also do some smart stuff, so we'll go a little bit further. So if you've ever been the analyst who's pounding the data warehouse, I'm sure you've gotten the angry email from the DBA saying, please cease and desist, stop writing select stars from my data warehouse. I'm going to ban you, basically. I've gotten it internally at Microsoft, so I know it happens. So we did a lot of smart stuff to make it as small of an impact as possible. So the top part is just auto-generated objects. You guys don't have to worry about it. But there's some steps that you have to go through with Polybase that we do for you on your behalf. And we make it pretty easy for the DBA to go audit and track what those are. The next piece that we do pretty intelligently is we do column projections for you. So you're not moving the entire data set across. If you only need one column, we'll project the one column in a SQL statement to SQL Data Warehouse. And then we move that single column back to Databricks. We also do limit pushdowns. So Databricks does a great job about not overrunning your browser. If you do a select star, it doesn't actually do a select star. It does a select 1,000, right? Because you don't need all that data to just come back to your browser and take it over. So we'd actually propagate those limit projections down into SQL Server or SQL DW. And then finally, to make your DBAs happy and everybody auditing what's happening, we tag the query so that they can understand at the end of the day how much traffic am I getting from the Databricks cluster. And then they can individually track that information. So that's on the case would be you're reading data from, you're writing in Databricks, you're reading data from SQL DW into Databricks. But the whole ETL part is about exporting. So we've gone through all that transformation. We've flattened the JSON. How do we get that data into SQL DW so that we can do the final part of getting it into our DIMFACT table? And again, this is super easy from a Databricks point of view. You use the same connector with the format. Oops. But all you would do is specify the table that you're going to write to. You specify the mode. So on the very bottom, you see in this case, it's overwrite. So I'm going to overwrite this table. So you can imagine it being a staging table. And you'll see the pre-actions and post-actions from ETL point of view. What I'm trying to do here is I'm trying to say I want to log when I start the load, and I want to log when I end the load. So I can keep track of this within the database. over time, saying how much data am I moving, how long is it going, are there any performance regressions, do I need to keep track of this? So this can all be done within the same statement, and they make it super easy for you guys to actually develop this, because this is a single line item in a notebook, which is pretty remarkable. So what's actually happening at a high level? And this is for both cases, which is why I made it a simple case. So remember that storage blob parameter I discussed that we're going to talk about? So you define where you want to land some temporary files, right? And so if you're doing, let's do an export case, what you're going to say is, OK, write the data from Databricks, which is on the far left, with the master and workers in the blue, and SQLDB is on the right. What you're going to end up doing is save the data, which writes a set of Parquet files to blob storage. We connect over JDBC from Azure Databricks to SQLDB, and then tell SQLDB, hey, go pick up those files for me. You'll notice that they're both in Parquet file format, because as Mark was saying earlier, Azure Databricks is hyper-performant on Parquet. Polybase also is hyper-performant on Parquet. So it's our fastest data transfer file that we have, and it also reduces a lot of the complexities that like CSV has, because CSVs are easily encrypted, there's easily encoding problems, they're hard to deal with sometimes. Parquet is a very rigid file structure, and since both sides are owning the contract, the data will move 100% of the time. So that's how it works under the covers. I just wanted to give you guys a little bit deeper dive into how, and also why SQLDB, why do we keep talking about this thing, and then not actually showing you how it works under the covers. So with that, I actually want to dive into the demo and hand it over to Mark, and we can see how this actually works all together in Spark and in Databricks.
All right, so we put together a demo for you. And it's going to be a notebook, and we're going to go through basically all elements of the ETL. Am I on the wrong? I'm in the right guy, right? OK. And so what we're going to do is we're going to go through kind of the very common elements of an ETL data and analytic process. What we're going to do is we're going to act like we're a retail store who is getting a dump of clearance data that they're paying for from another company, where they're going through to like websites like Walmart and Target, and they're looking at the types of clearances that they're putting the same products on. And they're going to combine this data, do some ETL work, use some machine learning models that have been built for them, and output it out to SQL Data Warehouse. So the first thing we have to do is connect up to the SQL Data Warehouse. Right here, we're using that same command that Casey showed us earlier, and we're pulling back a table called products. And what it's doing, it's putting, we can see it in this kind of table structure where we're getting a product ID, what the producer is, what the category is, just some general retail data. And then we're going to take a look at this data that's been dumped for us in this blob storage. And I'm going to read it in as just a text file right now, so we can take a look at sort of what this data looks like. I know it's kind of hard to see up here, but on that third line, we have some corrupt data coming in. So you can see it's single line JSON key value, and then that third line is corrupt. So we're going to have to take care of that. So one other thing that I want to apply is a schema. We talked about being able to infer the schema versus to have a user-specified schema. In order to speed up the writes, I'm going to apply the schema and force something. But also, when I go to read this, since I'm doing more like a machine learning, this is going to be applied into a machine learning model, I'm just going to drop out that malformed line and move along with my analysis. And so this is what it looks like. So we're using the spark.read option of JSON, and it's parsing all of those single-line JSON files now in this clean table structure that we can apply some other transformations to. And that third line, you can see that we've successfully dropped out that column. I'm going to register this data frame as a table. That way I can apply some SQL transformations to it. You can work with data in two ways. In Spark, you can either work in it as a data frame, And you have to use data frame logic in R, Python, or Scala. Or you can register it as a table. You can use SQL, and you can register them back and forth, even in the same notebook. It's kind of hard to see. I don't know if I know how the zoom is, but the size of the data that we're working with is 26 million lines of this JSON data. And it pulls it back, and I think it pulled it back in 12 seconds on the first call. It's all right for getting into the memory in 12 seconds. And then, just as the first data engineer, I'm going to just visualize the data a little bit, not trying to draw some analytical conclusions from these visualizations, but I do want to just make sure the distribution of the data looks at like it should. That way I know I'm pulling in the data correctly. So this is using a bar chart just to see the distribution of the different producers that I pulled in. That looks accurate. In this case, I'm looking at the distribution of the amount of sale prices that have come in, and this looks accurate. Think, for instance, if we had a large amount of these sale prices being at 80% off, maybe I would know something has gone wrong in the collection of the data, and we would want to go back to the data source to make sure our data that we're requesting is valid. And then another common pattern to the ETL pipeline with Spark is that I'm going to dump the data off. I'm going to partition it intelligently by date, so that way I can optimize for queries like, hey, give me all Tommy Hilfiger, on sale at this price past this date, and it can speed up that type of query. And I'm going to put it in a Parquet format so it's optimized for reads. That's going to be for data scientists who might be working in other notebooks to build out more machine learning models, not necessarily a part of the end of this ETL pipeline, but we're preparing the data for them in the process. The next component of this, now that we've pulled in the data and we've written into an optimized format, is we're going to apply the transformations that we want to make to the data before we load it in the SQL data warehouse. In this case, maybe we've had a data scientist who built a machine learning model for us. What we've done is we've pulled in a machine learning model that's it's a clustering model. So maybe they've identified based off of the sale price and the number of times it's on sale. Maybe there's different types of clustering analysis that they want because of it. So we've joined the two data sets together. We apply the machine learning model, and we can see that we have a distribution of our data that ends up in each one of these clusters. And afterwards, we're going to join that scored model back to our original two data sets that we've also joined together and write it back out to the SQL data warehouse. And that's what we have for our machine learning model. On all one notebook, we're able to pull data. Just to recap, in one notebook, we're able to pull the data in. We can work with multiple different types of data. We have the structured data, we have the JSON data. We can fix schema, we can fix the underlying data type. We can pull in machine learning models and score it, perform some basic transformations, and then output the data to SQL data warehouse. So did you want to come up and, yeah.
Thank you, everyone, for attending. We have 10 more minutes left, so if you have any questions, we are here to answer.
In the Databricks that you guys were in, how are your data factory and your data warehouse playing a part in this, actually? And do you need to create connections in Databricks to talk to data factory, or is it the other way around?
Yeah. OK, so I think this question, if I have it right, is kind of how does Databricks in this notebook integrate into the data factory pipeline?
Yeah.
So what happens is this notebook can be run via REST commands. So through REST, you can start clusters, you can run jobs, right? And so what Azure has done is that inside of the activities for the data factory, one is going to be starting the cluster, executing the job, getting the results, and pushing it back down to the next level of the pipeline. In this case, all we would have to do is run this notebook from the Azure Data Factory, and we would be able to take data from the blob storage, from the SQL Data Warehouse, do our transformations, and then push it back to SQL Data Warehouse. Yeah. Yeah. Yes. Yeah, it would just be one part of it. Yeah, this just happens to do multiple steps, but maybe it doesn't. Maybe all it does is do some other transformation, put it back to blob. Maybe something else puts it from, takes it up from blob, does something else, and moves it to the next activity. Yeah, it's just one component.
And the idea there is flexibility, right? Like knowing ETL is always very custom to the business and the business needs. So providing a very flexible format, whereas Databricks is on-demand Spark and custom coding, and then you can use Azure Data Factory as the orchestrator. It really allows you to be flexible and evolve as you need to your ETL process. Sorry, yeah, there's a bit of a queue.
You want to get to the queue? Or you want to? Yeah, sorry, there are several. So a couple of questions, right? The first question is on Azure Data Factory. So we actually used the Data Factory before for our ETL solutions. And one of the challenges was we have lots of talents, lots of customers, each talent have their own database. We move the data to the cloud, to the different areas in Azure's blob. So the challenge was in the monitoring, because we can monitor a single pipeline for a talent easily. You can go to Azure portal or put into Azure, the monitoring of those. That's fine. But as a company, right, when we build all these pipelines for all these talents, we have thousands. So I want to have a group view. I want to see with this 1,000 customers, all these pipelines, which ones has problem. So there's no way we know. So we were actually requesting a feature, can we have those monitoring capabilities? So just want to ask, if you guys have anything on that.
Yeah. So to repeat the question is how do I monitor the end-to-end pipeline with multiple different pipelines, activities in the pipeline, different data sources, and what is the right place and what is the right path. So as we talked in the demos, so the right place to monitor your pipeline is, you see when you log into the Azure Data Factory, you see this monitor tab, and on the monitor tab, you will see all your pipelines. And you can even filter these by triggers. So let's say if a trigger is basically how you are scheduling, right? It could be a tumbling window, or it could be based on weekdays, or however you have scheduled it. So you can filter this based on trigger pipeline. And then each pipeline would comprise of multiple activities, right? So if I go back to my pipelines, let me go back to this guy. If I go to my pipeline, what you see here is different pipelines are different. There are multiple pipelines that have been created. This guy, okay, looks like some browser issue. But basically, in the Azure Data Factory, yeah. So these are my pipelines that are there, and I have organized this into based on your different activities, where there is some file copy to blob, or some transformation, or an end-to-end orchestration, right? And all of these monitoring, you can just do it directly from Azure Data Factory, and which is the tool to go. But there are cases where you are just using Azure monitors or log analytics, where apart from these end-to-end orchestration, let's say you just want to monitor your Databricks clusters or something else. And that is yet another venue to get another holistic picture of the not just ETL, but your other scenarios as well.
But this, to me, still, we actually used this before.
Okay.
This to me is more still in a single talent level. What I was talking about is I have thousands of talents. Okay. Each talent has multiple pipelines. You have say 100 tables. You set up 100 pipelines to move this. So you do the math. That's huge amount of activities, pipelines. Okay. So as a DevOps person, I want to quickly find out, say, maybe 10 out of these 100,000 has problems.
Got it.
Can you tell me that?
Yeah. So the question is, this is specific to a single tenant, but what if, as a DevOps process, you have multiple organizations who have different AD tenants and different pipelines in each of the different tenants? And one option would be to just use this for different tenants, or if you're looking for a single pane of glass, then you would go to this Azure Monitor, which we talked about. And here, basically, you would be able to see all your, not just data factory, but even other instances across different tenants. And you have the option to select, change the tenant, and set alerts. Because as an admin, you want to get an alert, and you can just configure it from the monitors page.
One feature we were actually requesting was to, can you guys build more like a dashboard kind of view? I can see all those talents all in the same page. Because here, sure, I can drill down into individual talent, individual pipeline, but that will take a lot of time, right?
Got it.
It's really not cost effective.
Got it.
So.
Yeah, so that's good feedback. Let's chat offline more on your specific need, and we will look into and connect with the right person.
Yeah, I'm sorry. I have another question on the data warehouse. And following this same scenario, right, we have multiple talents. So when we put the data into the data warehouse, what is your recommendation? Do I use one instance for like a single talency model, or I will use separate data warehouse for different talents? Those are the key.
Yes. So the question is a multi-tenant versus single-tenant model within SQL Data Warehouse.
Right.
It often depends on the business model that you're trying to achieve. We have some customers who can do multi-tenant because they ship data to the customer, right? So they're selling the data as what they're making the revenue off of. So they have a combined data store, but the individual customers cannot access the data. They ship it via a SQL DB or something like that for physical isolation. What we often see with businesses is they may be selling data to direct competitors.
Right.
And it makes more sense just from a legal kind of good business practice to physically isolate those. So there's never any worry of, could they see my data or anything like that? Not that they can, because you can put security in place, but it's the perception which is often dangerous, especially in that type of space. So it depends on how much data you have, whether or not you need to bring it all together or to split them up into multiple data marts. Personally, I generally say start with single tenant, evaluate that option. If you need to go to multi-tenancy due to business reasons, saying we need to resell these costs and then it becomes too expensive, then we can discuss how to actually get that done. But traditionally, it is single tenant model is our best use case.
Right, because that's actually kind of our thinking as well, because sometimes we could need to do the queries across tenants.
Yes.
Because if you have physical and the separate data warehouse, it's so not possible to join them together, right?
Yeah. So I would actually love to talk to you more about this particular use case, but offline, just so we can get through everybody's questions. I can give you my business card if you just wait until we get through these. Then this is something I'm definitely interested in, of how to actually solve your problem, but it gets very specific about what you're doing, what you're selling, what your business model is, and so solving it right now would be kind of hard.
Okay, great. Thank you so much.
Yeah, no problem. Thank you.
Up to now, we'll be using Lake Analytics to do that pre-processing stuff, using Hortonworks implementation in data lakes and Lake Analytics, and then using T-SQL inside the data warehouse to pull the Hortonworks tables and doing all that, so an ELT model. How have you ever benchmarked the two against each other, the Hortonworks versus the Spark ML implementation?
Yeah. I mean, it's certainly, benchmarking performance is a difficult thing. I'm not trying to, push off the question, because data types are different and the types of processes that you want to do, can be different and change the performance. But generally, yeah, I don't think that the performance of Databricks is Spark over, Hortonworks if they're using Hive or something like that, it's much faster. Yeah.
We can say from the loading perspective, it's going to be about the same, right? And so if you're writing to about the same number of files of the same format, getting it into the data warehouse won't change. So it very much is the conversation of TCO that I would start looking at of those two implementations, not just raw performance. Because if you shave off 10 seconds, but it costs more to keep something up all the time, then...
I was hoping you'd done some of that TCO work yourself. That's why I'm asking the question.
Do what now?
I'm hoping you'd done that TCO work yourselves to tell us.
I generally don't like to go one way or another. I don't know what you're doing with that the Hadoop cluster. So if you're using HDI full-time and you have HBase on it, it's a very different conversation than I'm spinning up a HDI cluster with Spark just to do this data aggregation versus Databricks. What I can say is if you're going to do exclusively Spark on Azure, the recommended approach is Azure Databricks. So this is what we believe just from the stuff that Mark said in the beginning about the differentiators of Azure Databricks and some of the things that aren't in open source Spark, it will be faster.
And you're demonstrating a lot of preview software here, which is GDPR not compliant at the moment. So we really want to know when you're going to GA Data Factory version 2.
Yeah, so it is in the roadmap and it's going to happen soon. Yeah, so
how soon is soon?
It should be sometime in H1 is what I can say.
Yeah. All right. Okay.
Hi. How often the Databricks updates will come to Azure Databricks?
What was that? I'm sorry.
How often Databricks updates will come to Azure Databricks?
Oh, as frequently as 2 weeks. I mean, I think Azure Databricks is the premier product for Databricks, or it's the premier, product that we support.
Ah, okay.
Yeah.
All right. Cool. Okay. So one specific question about the JDBC driver. Can you run like a specific SQL statements instead of just tables, query tables, and write to tables?
If you wanted to like formulate a query inside of the poll from like SQL Data Warehouse.
So like for example, I want to run a store procedure. Or,
Yeah.
In a regular SQL, JDBC SQL,
You can. So calling the stored procedure is one thing, but running a full select star and hoping that you can get all the data back across the wire via JDBC is another thing. So if you're orchestrating things, JDBC is fine because it's sending a single connection over and then waiting for that to complete. I would not use it for data transfer. Use the Databricks connector, which is why we built it, for data transfer because it is the optimized route on both sides of how to move data. And then all the complexity is actually handled for you, so you don't feel that much of an impact, but it is the fastest way to move the data.
Okay, sorry, if it's not a data warehouse, I mean, if you just want to do like a regular SQL, Azure, for example.
Yeah,
right?
so you can construct a SQL string, and you can say, go execute string, right?
Over JDBC?
Yeah.
Yes.
Yep.
Okay.
Yeah, so that's a common way for people to actually go interact with databases, and the Databricks documentation is really great on this. So they give you a couple.
I couldn't find it there.
You couldn't find it.
Yeah, I just saw like when you write data, overwrite a table or read data, but with a table, but not really. For example, if I want to run truncate table, you know how to do it.
Yeah, that might be something to talk to me offline about. And
All right.
We can take that. I've definitely done it, so it works.
Yeah.
At least on my machine, right? That's
Thank you.
developer.
Works on your machine.
Yeah, so in link service, right, instead of personal token, can we use service principal? Like, because person can leave organization.
Yeah, so it is in our roadmap that what we will allow is the authentication. So right now the authentication is happening through the REST APIs, which is dependent on using personal access tokens. But in our roadmap, what we will enable is authentication using Azure Active Directory for the REST APIs of Databricks as well. And once that happens, then you can use a service principal or a user identity for authentication between Azure Data Factory and Azure Databricks.
Okay. So the second question I have is for HDI cluster, we have lot of freedom to secure the cluster in NSG, routing table, VNet, but how about Databricks like Azure? Because I don't see anything like we don't have any control over the cluster, right? Like.
Yeah. So when you think about Azure Databricks, you should think about is more as a fully managed service where you don't have to worry about setting up the NSG route, setting up the UDS, or setting up in a VNet. When you go ahead and click a workspace and deploy a workspace, it gets deployed in a virtual network, which comes with a default set of NSG rules, which means your inbound is basically locked from any of the access except from the control plane, which needs to monitor and manage the cluster and the resources within that VNet. Okay. So since it is a fully managed service, of course, you don't get control today to manage the network NSG rules, but the fact that it protects from any inside attack, given the fact that it has inbuilt NSG rules, your deployment of the workspace is protected within that boundary.
Okay.
So we take away the worry from you to configure and rather configure it as part of the service deployment.
Okay. Okay. Thanks.
Yep.
Hi. My question is for Casey on SQL Data Warehouse. Today we offload all reporting activities from our OLTP servers onto a dedicated SQL enterprise server, which acts in the capacity of a warehouse. So there is no cubes or anything of that sort, but just simple plain data sitting in a database, right? So, and we do that by constantly replicating through transactional replication from our SQL transact OLTP servers onto the warehouse servers, right? So sidestepping the data bricks, right, and all the transformations that comes fanciful with this. Can we just use SQL replication, to pump data to a SQL Azure warehouse?
Yeah, so the question is, can we just use like traditional SQL replication to move from operational stores into SQL data warehouse?
Yes.
Not today. We
Okay.
see much better performance with batch-based, so we traditionally see like an hourly offload of data
Okay.
and then loading it. So we can dive into the specific reasons why, but SQL data warehouse is much better at batch operations, in particular batch loads.
Okay.
So things like replication or transaction replication or singleton inserts, which really are the bane to large MPP systems.
Okay.
So you usually put too much overhead on the machine, and you actually don't get the analysis that you want.
Okay.
So we do see most people go into hourly diffs or every 15-minute diffs, so like a micro batching type of strategy.
Okay.
And then move those from on-prem to blob, and then you do a kickoff with ADF or something like that.
Okay.
So it's much more of a micro batch strategy today
Okay.
than a transaction replication across multiple.
Okay. The second part of my question is, so all the reporting activities happens through SQL reporting services today to a SQL warehouse. Can we have SQL reporting services connect to an Azure warehouse and still deliver the reports?
Yeah, so SSRS uses, I'll keep it at the same spot. So SSRS does support SQL Data Warehouse. Now, what you may want to do, depending on the volume hitting those reports, is do something like store data sources or store data sets within SSRS, because there's a SSRS service or server. And from there, you could have a bit of, how do I describe it? A little bit of buffer, because what we often see is the one report that the entire organization hits in the morning, right? Like a sales report from the previous day. You may have 3,000 plus users hitting that pretty quickly. And serving that volume, you often want to put a buffer in front. So we say SSAS, or when you go into Power BI Premium, you start to have MBI caches.
Okay.
And so you leveraging the cache right in front of the BI layer, even though we have multiple layers of caching, it's really how many things can we serve simultaneously.
Okay.
There's a sweet spot of like 60.
Okay.
And then as you get up into the thousands, you really have to look about how do we take advantage of what the BI tools are building and pre-aggregation and things like that.
So you're basically asking for a SSIS to transform the data sets into a pre-consumable format, so there is no online processing.
So pre-aggregated or even tabular models, but those are in memory, right? So you're paying just for that small buffer. What we often see is when people do BI, they'd say last 30 days, last 60 days.
Got it.
And it's a very simple thing that they want to see, and it's usually pretty repeated.
Perfect.
When the analysts want to go a bit deeper and they want all of the data, then SQL Data Warehouse really pops, right? Because it's all of the data, it's stored, and it's actually to get them up off the ground. So think of it as flat dashboards. You want to get that pre-canned as much as you can just for the analyst experience. Drill throughs are the case that you can say, okay, now you leverage the SQL Data Warehouse to back whatever the next level of insight is.
Okay, thank you.
Yeah, no problem.
Somewhat related, I guess similar. Instead of using data warehouse, so I don't want to say we're not interested, but that we're at this point we have a VM running SQL Server running in Azure, right? It has VNets to all of our internal stuff. If we wanted to use Data Factory and Databricks to do kind of the ETL for all the files and dump the data into that VM SQL Server instance, you mentioned that it spins up its own VNet. Can you tie those things together, or do you have to use the data warehouse is really the question.
So today, what happens is when a Databricks workspace is deployed, the lockdown is at such a level that it would not allow any outside resources to be deployed in that VNet. And the reason for that is primarily from a security perspective. The only communication that happens is within the nodes of the cluster that is deployed as part of the VNet within Databricks. Now, for your scenario, you would have to deploy that VM where you are running SQL on an IS within a VNet, and then configure an integration runtime for Data Factory to initiate the data transfer or data movement in and out. which will ensure that this guy, which is the VM, which has its own VNet boundary, Databricks has its own VNet boundary, and then you are orchestrating end-to-end through the data factory. So to answer your question, today you cannot deploy any other resources other than the Databricks resources in the Databricks VNet.
Mine's a kind of a quick question, but our situation, we've looked into sort of lift and shifting a SQL data warehouse or SQL database data warehouse that we have into Azure Data Warehouse. But as we dig into it deeper, we find all these things that don't quite work in Azure Data Warehouse. For example, some of the indexing and things like that is very different. I'm wondering if in the roadmap for Azure Data Warehouse, is the plan to bring more parity between, in terms of like, maybe not indexing, but like the functions and things like that are supported?
Absolutely, and so the question is like, as we move forward, is there a plan to bring parity from SQL Server, SQL DB space into SQL DW? And that's absolutely. Some things are much easier than others. To name a really hard one, cursors are actually extremely difficult to parallelize. But some things like syntax or anything like that is on a per customer demand basis is what we're going after, not a holistic, we will be 100%, but as these crop up, the vocal, there's user voice for SQL DW, we highly suggest putting that there and just trying to get votes for it. I can also give you my card so we can dive into your specifics of what you're looking at. Some of them we've heard before, some of them come out of the woodwork and like, oh, we've never thought of that particular case.
Things like coalesce and things like that.
Yes,
right?
yeah, then string, just general T-SQL syntax, yes.
Yeah.
So I would be happy to chat with you more about your list and kind of what's causing the code migration to be difficult, and then we can work through those and prioritize them against our roadmap. But SQL Server has been around for a very, very long time, and so it's matured in interesting ways, as well as SQL DW, because it's fundamentally a different architecture, cannot achieve things with the same performance characteristics or the same expectations that SQL Server could. Right. So there is questions of implementation at some point where they're fundamentally different architectures. So having that conversation with you, figuring out what you want it to do, and then we can say, okay, this may be slightly different, but does it meet your expectations or meet your requirements? So that's definitely why I'm here to talk with folks today, to work through that. So. Cool. Yeah, if you just wait a couple minutes, it looks like we have one more question. I'll give 2 cards out.
Yeah, I was just curious about your thoughts on trade-offs between SQL DW and HD Insight Interactive Query from the context of like exposing data lake data, both big and small, through a SQL interface.
Yeah, so I will say, I'm going to jump on this one first with my bias. If the data is relational, I say put it in a relational database. You're going to get some better performance out of that than having to pull from files every time. If you're saying, but that comes with a trade-off because they are generally more expensive. So it's really high-value data that you flatten down and you say, this is my curated enterprise data set. I really care about making sure that this is always right. I would pump that into something like SQL Data Warehouse. Now, we talked about cases where you want to keep the raw files, you want to keep the raw JSON for that deeper analytics on the side. That's a perfectly valid scenario, and we see a lot of customers do that, where they actually have multiple, I won't say copies, but multiple layers of data where they have raw data that they never want to delete because they want to be able to go back and find insights. They have a curated data set. They've gone through that first layer of prepping and they've taken out the malformed and it's a bit more queryable. And then they basically have their golden bits that they end up pushing to SQL Data Warehouse and reporting on that, because something like financial reporting, you want to make sure that it's right. You want to make sure that you can audit that family of, or that history of where the data's been so that you can restate if you ever have to. So it depends, I would say. But I do think it's a better together, which is part of the reason we partnered and part of the reason we wanted to give this talk is there is a better together scenario here where some set of analysts need more data or different types of data than others. So I would say for the curated set that your enterprise is running on, getting it into a data warehouse would be the best bet. I don't know if that's different.
I think it's all just use case dependent. I think, the beautiful thing is you pay for what you use. So if you want to work with streaming data and you want to do machine learning and you've got some structured data you want to work with, then you have Spark and Azure Databricks to do that type of intense learning with. But then the use cases that I think I would use for SQL Data Warehouse, I just wouldn't even think to use Databricks on. So I think picking the tool, then trying to pick the use case is probably the wrong way. Picking the use case, then knowing that you have all these tools available the right way.
Yeah, that helps. Did we answer it? All right. So thank you who have stayed till the very end, or the bitter end, as we say. And I'll get cards for everybody.